Hi, everyone. Today, we are going to explain the third part of the compound interest. And in this session, we are going to have a deep study about some calculations related to compound interest. Okay, so because in the previous session we gave and we explained the definition of the compound interest, and also we explained how to use the formula of the compound interest. So what we are going to do in this session. So at this time, sometimes we have some known values and we want to find the unknown. For example, at times the final amount of an investment is given. Sometimes we have the final amount and we want to calculate, for example, to find the principal if the other terms are given, like the time period or the interest rate. Or sometimes we want to calculate the time period while the other amount, like final amount of investment, we have the principal and we have the interest rate. So one unknown, one equation. What is the equation in interest? The equation is the formula that we already have. Big A equal to P, the principal factor, 1 plus big R power exponent N. Okay, good. We should be very careful when checking the compounding period and to substitute correctly to the terms and the values to obtain the intended answer and unknown. For example, in this example, we want to find the principal when the final amount, good, is given, rate is given, period of investment is given. We should be very careful when talking about unit per annum, years, good. So we are in the safe side, okay? We are working in the safe side. We are safe. So good, we can start directly, start immediately to use the formula that we know about the compound interest. A equal to big P, factor 1 plus R, exponent N. So first of all, calculate how much money principal must be invested. So we are looking for the principal. We are looking for P. So if we have this equation, so normally 1 plus R, P, we want to get rid of this factor, okay? We have between P and this factor, we have a multiplication. So moving to the other, or to the left-hand side of the equal, the multiplication becomes a division. So normally P equal to the big A over 1 plus R, all these terms exponent N. Good. So normally we can easily substitute each term but by its value. Big A equal to have $10,000. So big A is $10,000. Good. Next. And the 3 years. So N equal to 3 years. So we substitute small n by 3. Per annum, 4%, so small r equal to 4, big R equal to 4 over 100, so normally 4 over 100, 0.04, so 1.04 as a constant multiplier. So easy to calculate. Big P equal to 10,000 over the factor 1.04 exponent 3 to obtain the principal should be $8,889.96. So easy, but be careful when corresponding the values to the terms, the convenient one. And we should be careful, check the compounding period, substitute the answer into the formula. For example, per annum, annually, years, per annum, annually, years. So all these are very convenient to each other, so we can use directly the formula, but sometimes is not. For example, here We want to compute, also calculate how much money must be invested. Also, we want to compute the principal, and we know that the principal equal to A over the factor 1 plus R, big R for sure, exponent n. But we have 6% per annum, interest compounded quarterly. Okay, we have some difference units and 5,000 2 years. Normally, we go to convert all these one to the smallest period that we want to compound the interest after it. So normally interest compounding quarterly. So each quarterly, so we mean here each 3 months. So we have four, so we, for example, or quarter of year. So per annum, 6% per annum. So if we divide it by 4, we will obtain per quarter. Per quarter. Good. So we convert it into quarter. This is into quarter, and we convert 2 years into quarter. We have in each year 4 quarters. So normally 2 years is about to be equivalent to 8 quarters. 8 quarters, because 2 by 4, sorry. And then we substitute all these one. So 2 small n is 8. Big R is 6 over 4 divided by 100. 6 over 4 is 15. 1.5, and 1.5 divided by 100, 0.015. So normally 0.015 to obtain this one, and then we use the formula to obtain the principal should be $4,438.56. So calculate the value of big R and N. In general, R is divided by the number of compounding periods per annum, and N is multiplied. N is multiplied, big R is divided. Okay, that's what we did before. And the same, we have a per annum, we have a 3 years, we have a quarterly. So quarterly 3 years is 3 by, we multiplied. The N is multiplied 3 by 4 quarters per annum. So normally 12. So small n equal to 12 in quarters. Per annum, so 8 divided by 4, because you know the rate is divided. We divided by 4 to obtain 2% per quarter. So per quarter, so when we want to calculate big R is 2 divided by 100, and so on. We put it in the following equation to obtain this principal that should be. And sometimes they ask us to find the annual compound interest rate. We want to find the rate. Okay, the small r. When the principal, we have the principal, we have the final amount, and we have the period of investment are given. So normally we use the same formula, big A equal to P by 1 plus R power N. Normally, to obtain the small r is directly proportional to the big R, because we know that the big R equal to the small r divided by 100. So if we find big R, we multiply it by 100 to obtain the small r in the simple cases when we compound yearly. Okay. Okay, so yes, we want to start. So normally what we are going to do, that I want to explain it in this formula. We have this formula, and all the terms inside this formula are given. We are going to find big R. So we want to isolate R here. So first of all, we have a P, we have a bracket. So we want to get rid of P. P goes or move to the left-hand side of the equal as division, as denominator. So big A over P. Or the 1 plus R exponent n equal to A over P. And to get rid of the exponent of the power, we have the nth root. The nth root of A over B equal to 1 plus R. And if we want to find a big R, so big R equal to the nth root of A over B plus 1 becomes minus 1. We can say it that we move the plus 1 to the other hand side of the equal. So it becomes -1, or we can say that we subtract -1 from both sides of the equal to obtain nth root A over P -1 as R, big R. Okay, so we substitute at this level, we can substitute all the amounts that we have. So to increase 450 to $5. Normally, the greatest value is for the amount of investment, the total, the final amount of investment, and the smallest one is for the principal. It refers to the principal. 3 years, 3 years. So normally n equal to 3, and we put it inside the equation to obtain this value. Normally, to calculate the annual compound interest rate, so we multiply it by 100 to obtain 3.6%. But sometimes we have the same values, but when the interest rate compounding monthly, okay, monthly, so it is a little bit different because we have here monthly and instead of yearly. So we should convert all the compounding period into a month. We know that 3 years, and each year we have 12 months. So we multiply, as I said before, the compounding period by 3 by 12 to obtain 36. So n equal to small n equal to 36. And in this level, we will obtain the small r or the big R. We will obtain it in a month. So normally we calculate and we can use the same formula because we have the same terms. So we can say that 36th root of 1.4. Okay. As we see here, and also we subtract 1, okay, to obtain as a big R this value. This value in a month. But if we want to calculate the rate per annum, so we multiply it in month, we multiply it by 12, then by 100 to obtain 11.27% per annum, and so on. So also it is very easy to imitate the same thing that we explained before, okay, in the exercise 19. Sorry, in the exercise 19, to find what we are searching for. I'm going out of our battery. Okay, good. So in the same way, we have exercise 19. We explained why big R equal to nth root of A over P -1. And we know that's a small n equal to 4 years. And we are very interested to calculate over months, each month, monthly or each month, the interest. So we should convert it into months. So 48 months. So 48th root of A over P -1, and we obtain the rate per month, and then we can calculate the annual compound interest rate by multiplying big R by 12 to obtain per annum, and by 100 to obtain it as percent per annum. So 5.6% by annum. What about the final case? I didn't mention the final case. In the final case, we want to calculate and define the value of the small n, the compounding period, when the big A, the big P, the principal, the rate of interest per annum are given. Okay, so you should know that we will use the guess, check, and refine to calculate the guess, check, and refine methods. How? We should try different n. Okay, first of all, here, if we try n, we are also using the same formula. If we try n equal to 3 years, so it will give us 6,945. It is biggest and greatest than 6,000. So normally it is too small. N is sorry, we want to have 7,300, so it is too small to use. So we go to try n equal to 6, and it gave us 8,000. 8,000 is bigger and greatest than greater than 7,300. So n is with x is too big. So we go to use the 4, and 4 give us a very close 7,293, which is nearly approximately equal to 7,300. So yes, it is the convenient one that we are looking for. So we try different values for n. If the value is less, then we use the bigger value to obtain finally what we are searching for. And I tried my best to use different ends here, different guesses, and to check it and to refine it to obtain finally that n equal to 7 is the best to get the ended goal. Thank you for listening. These are the important information that we seek to explain for today. And have a nice day.